Okay, so for your third bonus one, let's just do a simple transformation of a stress state. So imagine we've got a stress state here. What shall we have? In a planar. So we'll have 60 kilonewtons going off in this direction. Got 40 in this direction, compressing it. And then we'll have some shearing going here of 20 kilonewtons. So we are going to work out what would be the stress components if we rotate this anti-clockwise by 30 degrees. So the first thing you want to do for this is to sort this out so that it's in standard kind of coordinate systems. So we're going to rewrite this as just using the top and the right. Get your arrows pointing outwards. So 60 is fine. 40 is going inwards, so we'll make that minus 40. And then on top, you want your stress to be going in this direction. Actually, they kind of draw them like this, with half arrows. The shear stress, sorry. And so that's going in the opposite direction to this, so we'll make this minus 20. Okay, so that's, once you've got it looking in that form, you're ready to use your transformation equations. And our transformation equations will graph from the formula sheet. Let's put them down here. Basically, all we've been asked to do is to plug our numbers in here, and our theta will be 30 degrees. So let's set this into degrees. Okay, so the new x component will be minus 40 plus 60 divided by 2 plus minus 40 minus 60 divided by 2 cos 60. 230s are 60. And then we've got another minus 20 sine 60. So that's our first result. Second result will be similar. So minus 40 plus 60 divided by 2. This time we put a minus here. Minus, and then we've got minus 40 minus 60 divided by 2 times this by cos 60 again. If you're cunning, you can maybe save this in your calculator and just change signs around. Minus, okay, so it's minus minus, so that becomes plus 20 sine 60. And then if we transpose the shear stress, so this will be the shear stress transpose, so that's minus, got minus 40 minus 60 divided by 2 sine 60, and then we've got a minus 20 cos 60 equals. So let's do our first two. So we're going to have minus 40 plus 60 divided by 2 plus minus 40, take away 60 divided by 2 times by cos 60, and I'm in degrees, take away 20 times sine 60, close the bracket, and the result is minus 32.3 kilonewtons. Let's see if we can go back and change signs and find our y dash. So we want to make this a plus. Okay, and we want to make this a minus. So that becomes y dashed is 52.3 kilonewtons, and those numbers kind of seem sensible. If I'm rotating this by 30 degrees, I'm still vaguely pointing left to right. So my minus 40 is becoming a minus 32. That sounds about right. So I'm swinging this around. My 60 becomes a 52. That sounds about right. So what we're going to get for the final one, for this we start a fresh calculation. So minus, let's open a bracket. Well, no, we don't need to. Minus 40, take away 60. Notice I'm being lazy, letting my calculator do all the work. Sine 60, take away 20 times cos 60. Okay, and I'm worried. Is that correct? Minus 20 cos, yeah, okay, alright, so apparently, yeah. So that's 33. Let's check that. What I'll do to check that is go back to my calculator, and I will see what happens if I only rotate it 3 degrees. Okay, only rotate it 3 degrees, and my minus 20 becomes minus 14. So that sounds like it's working. Half a degree. Yeah. So certainly that's fine. Okay, so I've rotated all my values around, and I'll leave it there. Other stuff you might want to look at for your revision. So the only thing we haven't really covered on the formula sheet is using the strain equations. What do I mean by the strain equations? So those of you that did the right experiment would have covered this, but maybe look at an example using some strain, and then you've covered, using the mock and using these bonuses, pretty much everything that you would want to do for the exam, I think. Okay, I will leave it there. Good luck.